Hey guys, this is your answer key for Unit 1, Lesson 2 practice. And again, I'm hoping you're trying some of these problems by yourself and just using these videos as a tool. Anytime you have any questions, just send me a quick email and I am available to help. But if we get started here, Lesson 2 was about corresponding parts and scale factors. So if we go ahead, question number 1, the second H-shaped polygon is a scale copy of the first. Show one pair of corresponding points and two pairs of corresponding sides in the original polygon and its copy. Consider using colored pencils to highlight corresponding parts or labeling some of the vertices. Vertices is just a corner point, okay? So to begin, name one pair of corresponding points. So if I pick this point here, corresponding, remember that means they're in the same place. So if I pick this point, it corresponds to this point here because they're in the same space on the shape. Okay, so share one pair of corresponding points. I did that. Now I want to share, I'm going to pick a different color, two pairs of corresponding sides. So if I pick this side here, what corresponds with that? The side that's in exactly the same space. So on the smaller figure, it's going to be this side. And then if I pick another color, I'm going to pick this bottom piece here. So what corresponds to that bottom piece? This same bottom piece right here. What scale factor takes the original polygon to its smaller copy? Explain or show your reasoning. So if it says show your reasoning, that means that you don't necessarily have to use words. We can show it in our math work. So remember, to find that scale factor, I have to figure out what is that number that takes one side to the next, always dealing with corresponding sides. So I have to pay attention to the language. It says what scale factor takes the original to its smaller copy. So that means I'm going from the bigger one all the way down to the smaller one. Okay, so if I'm going from big to small, I need to make sure that since I'm ending up in the smaller shape, I'm pulling that smaller number first. So I want to count my sides. So I'm just going to pick the blue sides that I already have my arrow pointing to. So here I have 1 unit. So now I want to go ahead and count that same measure in the larger figure. I have 1, 2, 3, 4. Okay. So then what is my scale factor that takes the original to the smaller copy? Since I'm getting smaller, I start with the smaller number first. 1 divided by 4. Okay. If you wanted to go ahead and write that as a decimal, it would be 0.25. However, I would prefer to leave you as a fraction. So if we wanted to go ahead and say the scale factor is 1/4. Okay, so main idea is to pay attention to the language. So it's telling you where you're ending up. So original to the smaller copy. Since we're going to something smaller, you're starting with the smaller number. Okay, if it said to take me to the larger figure, then I would start with the larger number and I would do 4 divided by 1. Okay, pay attention to the language and how it's written. Question 2. Figure B is a scaled copy of figure A. Select all of the statements that must be true. So we're going to read through them. It might be okay. Sometimes we might have to read through something more than once, but let's start with statement A. It says figure B is larger than figure A. Okay, so pay attention that it says it must be true. So if figure B is a scaled copy of figure A, does that mean B has to be larger? Well, no. I can have scaled copies that are smaller, right? If I think about this example here, if this is figure A and this is figure B, this isn't larger, but it's still a scaled copy. So that's not true, so I'm not going to circle A. So let's go ahead and just eliminate that so we can't see it anymore. Figure B has the same number of edges as figure A. Yes, if it has the same number of sides, that means it's probably exactly the same shape. So that has to be true. Figure B has the same perimeter as figure A. That's not true. Remember, perimeter is your distance around the outside. And again, I can use this example up here to help me. If my perimeter here, if I added up all of these blocks all around the edges, is that going to be exactly the same as if I were to add all of these up? No. Obviously, if I add the smaller shape up, it's going to be a smaller number than if I add the bigger shape up. So that's not true. Scaled copies do not have to have the same perimeter. Figure Question D says figure B has the same number of angles. Yes, that has to be true. It has the same number of angles. That means it's pretty much the same shape, and that's our definition of scaled copies. And then letter E says figure B has angles with the same measures as figure A. That has to be true. In order to be scaled copies, your angle measures have to be exactly the same. If your angle measures are different, it's not going to be the same shape. So there we have it. B, D, and E have to be true if it's a scaled copy. Moving on to question 3. Polygon B is a scaled copy of polygon A. So let's look here. So they're telling me that A and B are scaled copies. Question A says, what is the scale factor from A to B? So I'm going to draw my arrow to match that statement so I know if I'm getting bigger or larger. So from A to B. So I'm going to draw my arrow from A to B. That way, when I ask myself, is my shape getting bigger or smaller, I can follow my arrow and I can see. From A to B, my shape is getting bigger. Okay? So whenever I'm looking for my scale factor, I know I have to divide. We know our work for finding scale factors is to divide something. So then I just follow my arrow to make sure I know which way I'm dividing. So from A to B, my figure is getting bigger. So I'm going to take my bigger number divided by my smaller number. Okay? So big number divided by small number. Okay? So first, let's figure out our pair of corresponding sides. So here I can see that this line segment here corresponds to this one. I also know that my length of 1.5 corresponds with this, but I don't know what that length is. And then I have another one down here, a length of 2.5, but I also don't know what that length is. So if I'm looking for my scale factor, I have to make sure I'm pulling side lengths where I know both the sides, 2 corresponding sides where I know both of their lengths. Okay, so using my note here, my bigger number, I'm going to pick the blue corresponding sides because I know both of them. My bigger number is 5 divided by 2.5. So if you have a calculator, you can go ahead and use that. I have this big clunky thing. You guys might just have your scientific calculator. You can use your iPad. You can use an app that you have, any calculator. We're just going to go through and say 5. Can you see 5 divided by 2.5? And we're going to figure out what does that give us. So we can see it gives us 2. Okay. So then there is my scale factor of 2. So explain your reasoning. I can use that math work I just did to explain. I showed my pairs of corresponding sides with my color coding to the right. I showed my arrow saying that it's getting bigger. So I know I'm doing bigger divided by smaller. 5 divided by 2.5 gives me 2. So that's my scale factor. Question B says, find the missing length of each side marked with a question mark. So scaled copies tell you that whatever your scale factor is, so since I have a scale factor of 2, that means that all of my side lengths here, all of my side lengths in figure A are going to get multiplied by 2 to get side lengths in B, right? 2.5 times 2 gives me 5. So I'm going to follow that same pattern. To figure out my side length here, 1.5, if I go ahead, let's erase these. Let's use pink so that it matches. So I need to figure out from here to here. So my scale factor tells me that I can take the original side length, multiply it by 2, and it's going to give me the new side length. So if you need to use your calculator, 1.5 times 2 gives you 3. So this side length is going to be 3. And then I'm going to do the same thing over here for my orange side. 2.5 times 2 gives me 5. So my side length over here is 5. Okay, so there's question B. And question C, determine the measure of each angle marked with a question mark. So we should know that scaled copies mean that angle measures are the same. So if I know that these angle measures are given, they're going to be the exact same over here. So this big angle here matches exactly with this one. So this angle measure is going to be 82 degrees. And then if I know that this angle is 53 degrees, it's going to be the same thing over here. This angle is also going to be 53 degrees. Your side lengths are what gets scaled by the scale factor. Angle measures always stay the same. Moving on to question 4. Same thing we had in lesson 1, practicing with multiplication, division, opposite operations, things like that. So complete each equation with a number that makes it true. So question A says 8 times what gives me 40? So remember that if we need to figure out that missing piece of a multiplication problem, we can work backwards and divide. So 40 divided by 8 gives me 5. So that's going to be 5. 8 plus what gives me 40? So what do I add 8 to get 40? Again, think opposite operations. If I need to figure out the answer to my addition problem, I'm working backwards. What's the opposite of addition? We have subtraction. So we're going to go ahead and say 40 minus 8 equals 32. 21 divided by what gives me 7? So you might be able to think about this in your head, right? 21 divided by what gives me 7? That's going to be 3. 21 minus what gives me 7? So we can count backwards if we want, or we can just kind of take it and think about it the other way. 21 minus 7 is what? So again, in your calculators, if you need to use it, that's perfectly fine. What's 21 minus 7? That's going to be 14. And then 21 times what is 7? So with the multiplication and the division, it's not as easy to kind of count backwards like this. If I wanted to, I could just take 21 and count backwards and say 20, 19, 18, 17, all the way back. It's not as easy to do that with multiplication. So if I'm looking for that, I can say, well, what is 21 or 7 divided by 21? We can reduce our fraction. They both reduce by 7. So then I have 1/3. So 21 times 1/3 gives me 7. And there you have it. There's your answer key to Unit 1, Lesson 2. Hope that helped. See you later, guys.